Hey everybody, this is Alex Merced from AlexMercedCoder.dev. And in this video, what I want to do is just kind of do an introduction to backend development. So first, let's talk about what that means. Okay, so let me open up a fresh Excalidraw. So I'll make a new incognito window, head over to Excalidraw, and let's just sketch out what it means. So bottom line is this. When you experience websites, so like right now I'm looking at Excalidraw, I'm experiencing it in my browser. Okay? So there's the browser. So there's code that's actually running in my browser currently. Okay? So it's my computer that is processing that data. Okay? So if I were to actually open this up, like open up DevTools, Control-Shift-I. Okay, if I were to go over here in my browser and I can take a look, these are the files that were requested for this website to function. Okay, and I can actually go in here and like look at these files. So I can here looking at the index.html, and I can actually look at this specific code. Okay, there's some folders over here, like here's like the JavaScript, and there's like all the different JavaScript files, and I can take a look at them. That's front end code. So any code that when I'm looking at the website in the browser, I can see under the sources tab, that's front end code. Who is running those files? My browser. It's my computing power from my computer that's handling it. Okay. And because it's running on my computer, I can see it. I can open up DevTools and look at all the code. There's nothing you can hide here. Okay. So this will be one reason why you're going to want a back end, because nothing can be hidden in the front end. Okay. There are ways to obfuscate things from your GitHub repo, so that way people can't see it in your GitHub repo. And I am assuming in this video, if you're here to explore back-end development, that you have already some familiarity with front-end development, HTML, CSS, and JavaScript, and you have some familiarity with like working with like GitHub and things like that. If you don't have those pieces of experience or knowledge, I recommend getting those first, and then come back and visit me and watch the rest of this video. But bottom line is like I could theoretically go in here and learn like exactly like if you make an API call to some third-party place to get data, I can see all that data in here. I can just go here in the network and I can see every request that this website's making from my computer. I can see what API keys they use, what credentials they used. And the reason why that's important is, again, security. So oftentimes when you're dealing with credentials, you don't want to do that in the front end. Okay, so that's going to be reason one. Also, when it comes to the front end, the browser is limited. Okay, there's just, you can only do things that the browser lets you to do, which is mainly render a web page. And nowadays, there is a lot you can do with the browser, but there's still a lot of things you can't do, or you can't do easily. One of the biggest things that you're going to want to do is oftentimes store data. Like you can store data in the user's browser. You have things like local storage. So if I go over here to like application, there's things like local storage, session storage, IndexedDB, which are all mechanisms for me to store data in the user's browser. Okay, the problem with that, it's in the user's browser. So if they switch computers, their data is not on that second computer. Okay, so generally if you're building something like a social network, you need to have the data exist somewhere that is not the user's computer. This is where we generally have databases that are being run on separate computers. So that way, and you generally are going to want to handle all that talking to that database, not in your front end, because again, all that is visible to anyone who's on your website. You want it done in the back end. Okay, so the idea is somewhere out there in the web. So when I go in here to Excalidraw.com, when I typed in this domain name into the browser, my browser sent a request somewhere to some server. And that server is running software. And that's essentially the kind of software we're running today. We're going to be writing when we write backend code. That's this program then went back and sent over the HTML, the JavaScript, the CSS that my browser is now running. Okay, so the front end code gets run in the browser. The backend code is run on the server. So essentially, like my browser sends a request, says, hey, get me Excalidraw.com through the fanciness of the inner tubes, which involves things like DNS and your router and the way, TCP/IP routes data around. This request from your browser on your computer is going to end up to whatever computer in the world is running the server for the website you just requested. And that server software will then send back the files your browser is going to read. But this program here, this server program, that's backend code. Okay, so the server is the backend. It's not run on your computer. It's run on some other computer out there in the world. Okay, now we're going to write a server, but we're going to write it on our local computer. So it's going to be harder to see that distinction. Okay, there's going to be times where, we see code in our browser, and then but our server's running, and it's like, hey, this is on my computer, and people sometimes it's kind of hard to see that line happening, but it's there. At the end of the day, you're just having two different things, giving bits of your code being run in different parts of your computer, essentially. And we'll kind of go through all that. Other benefits of the server is you can write a server in any language you want because it's not run in the browser. The browser can only understands HTML, CSS, and JavaScript. But a computer, some random computer out there in the world, understands all programming languages that you install on it. So you could theoretically create a backend server program in any language you want. It's like, well, then how does my browser know how to talk to every language? It doesn't. Okay, they use a set of standard ways of communication, particularly what's called a HTTP request. So an HTTP request is a standard way of sending a message across computers. So it doesn't matter what language the software is written in, it's going to understand how to read an HTTP request. So that means any server can respond to that request. Okay, so bottom line is, again, browsers are going to send a request. The server then sends back the files, like an HTML, CSS, and JavaScript, and then the browser reads those files. Okay, so now let's actually put this into action. So I'm going to close this browser window, and I'm going to bring up my VS Code. I have VS Code open up to a blank folder. Okay, and I'm going to assume that you have Node installed. Okay, so we're going to be using Express, which is a JavaScript runtime. Okay, so we're going to be doing this backend in JavaScript using a framework called Express. But the same principles, the same ideas are pretty much the same regardless of which language and which framework you're using. The syntax may be a little different, but the ideas are the same. But essentially, since we're using Node, and again, you want to make sure you have Node installed. So the way you can check that is by doing like node -- version. That'll tell you which version of Node you're running. Okay. And once I've done that, what you want to do is you want to create a new Node project. But even before I do that, I'm going to create a file. So I'm going to create a file called server.js. Okay, and that's going to be our JavaScript file that describes our server software. Okay, you can call it whatever you want, but generally giving things names that exemplify what they are is generally a good idea. Now, once I have that file, I'm going to create a new Node project. And the way you do that is you type in npm init. This means initialize a new Node project, and I'm going to add a flag -y, which helps you skip all these prompts. If I don't put the -y, it's going to ask me a bunch of questions, and you can save yourself the trouble by just doing the -y. Just means say yes to all the default answers. So if I do that, it creates this new file called package.json. If you're not familiar with Node, the package.json file is essentially what tracks your project. Basically, it's like how how Node knows, hey, there is a JavaScript project in this folder, and this JavaScript project has all these different details that are important here. Okay. Cool. Okay, now assuming that you have a version of Node 19 or above, okay, you can use this watch flag, which I'll show you in just a second. So oftentimes what you want to do is you're going to want to edit these scripts. These scripts are just little ways to more quickly run a command. Okay, essentially you can run any of these scripts by typing in npm, oops, not there. Oops. Okay, but in your terminal you would type in npm run, and then you would put in the name of the script. So npm run test, npm run start, and whenever I do that, it's going to run whatever command I have here. Okay, so for example, I'll just get rid of all these for a moment. I'll just literally create a script called example. And what it's going to run is echo, which is a terminal command. It's a bash script because it just sends the command to, hell, it could even create files. So I can be like, hey, touch .env and .getignore, which are files I'll talk about in a second. Okay, so now if I type in npm run example, so again, basically what it's going to do is going to say, hey, I'm going to look in the package.json that's in this folder, and see, hey, is there a script called example? And if there is, it's going to run the command that's there. Okay, so if I run this, it should create two files, .env and .getignore. And see, that's exactly what it did. Okay, so again, this doesn't have to be a JavaScript command. It can be literally any command. Now, typically, we're not going to use it that way. Like typically, you use this to run a JavaScript file. So usually, what we're going to do is we're going to have a start script. Okay, and that should just run your file. So node server.js. It's going to run my server. But usually, when you're developing, you want to set it up that you don't have to keep restarting your server, because anytime you make a change, the file every time you run the file, it loads. But if you make a change to the file, it doesn't reload. So there is a way you can tell Node that when it runs your file, that if there's any changes to that file, to reload the server or restart the script. Okay, so we usually call that our dev script. Doesn't matter what you call it. It could be dev, it could be cheese, it could be whatever. But what you do is you use Node, and then you're going to add this -watch flag. And that's going to tell Node that, oh, I'm going to watch this project. I'm going to watch all the JavaScript files in this folder, and if any of them change, I'm going to restart this command. I'm going to redo this command. So node server.js. Okay, so like right now, I'm going to put a console log in here. Hello. Okay, now if I do npm run dev, it's going to run that dev script. And you see it says it's watching. So see, it's in watch mode. Okay, and see, it console logged hello. Now if I change this to hello2, see, notice it reran the file, and now I see console log hello2 without me having to explicitly run the file. Okay, so I don't have a server running yet, but the idea is that, like, again, in the future, once we have our server up and running, every time we make a change, we don't want to have to like redo it. Now, let's say you don't have, let's say you have an earlier version of Node, like you have Node 16, 17, something before this watch flag was added. Okay, what would you use instead? What you would do is you would install Nodamon, okay, which you would use this command for. So it would be like sudo if you're on Linux or Mac. You wouldn't need sudo if you're on Windows. Sudo npm install -g. So I'm installing an npm library, which is just like a package of code that I can use. So npm install -g means I want to install it globally. You rarely ever want to install anything globally. So don't install things globally unless you know you want to install them globally. -g, and then I would say Nodamon. And what this would do is it's going to install this Nodamon package globally so I can use it. Okay, once I have that, I can now, let's say, go back to my package.json. If I don't have the watch command, I can make it say something like, well, I'll just make it called dev2. So you can see another script. It could be you would use the command Nodamon instead, and you would say Nodamon server.js. Okay. So now if I did npm run dev2, see, notice it's using Nodamon, and see I got all this output here, showing that Nodamon's running. Right now it output hello2 because the script ended, but now if I type in 3 here, oh, there we go, and see hello3, it runs. So notice I didn't have to go run that command again. Because you have Nodamon or that watch flag running, anytime the file changes, it's going to rerun the command that you kickstarted. Okay, you only want that in development. You wouldn't want that in production. So just why we have our start script, so that way when you deploy your server, whenever you put this code out for the public to use, you don't want it restarting randomly. You just want it running for that. Okay, this whole restarting thing is purely for development purposes. It's purely to make it easier for us to see the changes in our code. Cool. Okay, so now we've established sort of setting that setup. Now, again, I said I added this .env file and this .getignore file for a reason. This .env file is typically used to hide sensitive details. Okay, we'll talk about how you do that in a second. This .getignore file is more for Git. Whenever you have a Git repository, you may have certain files you do not want to push up to Git, like that .env. That .env is going to hide all of our sensitive details typically, so we generally want to ignore that. That's going to tell Git to not push that up, not track it. Okay, you want to make sure you've never committed the file before you do this, or Okay, if you've committed the file already, then it's going to be tracked. It doesn't matter what the git ignore says. So you want to make sure you set up this git ignore sooner than later. So the two things you're generally always going to want to ignore for any node project is going to be that .env file and a node modules folder. You don't know what this is yet. We don't have this node modules folder here, but you'll see it in a second. Okay, you'll see that when we start installing other libraries that we'll need to build our project in Node, that you're going to need this node modules folder will appear. Okay, so again, this is just setup. So the thing is that Node by itself doesn't have the framework I need to build my Express server. I need to install it. I need to install Express. And generally in Node, you install everything per project. So for each project, so if I start another project, I'm going to install it again. It's per project. So I'm going to do, and you'll see here, like in my package.json, you're going to see it's going to track the things we install. Okay, so if I do npm install, and I'm going to install the things that I want, right now what I want to install is Express. Okay, because Express is going to be the framework we're going to use. Okay, if you look at it, you see like, hey, look, the dependencies got added automatically. Okay, that's how you know you did it right. If I don't see it there, then something went wrong. Like running the command in the wrong folder. You want to make sure you're in the right folder with the right package.json. But I also want to install .env, npm install .env, because that way I can use that .env file. Okay, wonderful. Okay. And that should be good for now. So now let's start setting up our server. So here in our JavaScript code, when you've installed third-party libraries, because again, right now we're just dealing with JavaScript, there's no HTML, there's no CSS, because we're not in the front end anymore, we're in the back end, and the back end is just going to be pure code. Okay. First thing I'm going to want to do is import my libraries. Okay, import the things that I'm going to be using. So one of those things I'm going to be using is .env. Okay, the way you bring in the library is a function that's built into Node called require. Okay, and what require does is that it's going to import a specified file or library. If it's a library that you installed via npm, you just have to pass the name. Okay, if it was a file, then you'd pass the file path. Since we're talking about the .env library, I can just pass in the name .env. What it does, it then looks, so essentially when I run this function, what it does, it actually looks inside this node modules folder for something called .env, which is right here. Okay, right there. And it's actually importing all this JavaScript that's in there. Okay. So where is all that coming from? It's in that node modules folder. But you don't want to have to push that node modules folder to GitHub, because you want to have to push the code for all these third-party things to GitHub. That's why we git ignore it. Okay. So you always want to make sure you git ignore that. Okay, now this .env library, the only thing we need to do with it is call one function. So we're just going to chain off of it. You know, actually even make it more straightforward. We'll just save it to a variable. So we'll say, hey, we're going to make a variable called .env, and we're going to save that library in there. So basically what this function does, it's going to return what that library brings in, and then we can save that into a variable. Usually it's going to be an object with a bunch of functions and things. So now that I have .env stored in a variable, I can now use it, and what I want to use is this config function. And basically, literally calling this config function, what it does is that it tells it to look to see if there's a .env file, and if there is a .env file, it's going to make use of those variables. Okay, and we'll see that a little bit later on. So bring in variables from .env file. Okay. And the other library we installed was Express, so we probably want to get Express. So I'm going to declare a variable, call it Express, and then I'm going to go require that library, Express. So that way now all the stuff from Express is inside this variable. Yay. Okay. Bottom line is I can't use it if I don't import it inside. Okay. It doesn't exist if I don't declare it. So now that I have that, we can create our Express application. So the idea here is the Express application object represents your app, and it's going to be the main way we configure to tell our app what to do. Okay, so we have to create it. So we're going to say const app equals Express. Express is just a function that creates the app. Okay, So now we have this app that represents our server, and now we need to create instructions of what this server should do. At the end of the day, all the server does is it just stays on. It's just basically this piece of software. The difference between a server and just a normal script, like you just wrote some JavaScript, is that if you write some JavaScript, it runs, and then once the code is done, it stops. Okay, so just to give you an example of that, if I were to write like script.js here, and I just do a console.log of hello, okay, and I just do node script.js, notice it just logs hello when it's done. It moves back, it moves on, it's done. That's just a normal script. Okay, a server, when we kickstart a server, it starts running and it never stops until you shut it off. Because what a server does, it's like opening a restaurant. Okay, when you open a restaurant, as long as the restaurant's open, it's taking orders. Okay, so your server is exactly doing that. It's basically, when you start a server, it's just opened up and it's waiting for orders. It's waiting for requests. So when we design our server, we're not designing the server functionality because that's already built in. So Node has already like server functionality built in, and Express just makes that using that functionality easier. Every language generally has some sort of like HTTP functionality for you to create an HTTP server. So I don't have to think about, hey, how do I make this program stay running forever? It's built into the language. Okay. So what I got to think about is, what are the kind of things that people can ask my server for? And the way people ask your server for things is they send requests to a particular URL. Okay. So oftentimes the main URL is always the root path. So here we'll say, route for requests to slash. Okay. And the way we do this is this app object has a bunch of functions built in. So you can see here is like a bunch of functions built into it. Okay. So we're going to say, hey, app.get. Typically, when you type a URL in the URL bar, it makes a get request. So we're saying, hey, this is going to be, we want to tell our application that when a get request comes in, and then the first argument you pass, okay, is what URL is requesting for. So the main page would be slash. That represents just the, like xyz.com. Okay, it would be slash. And you're going to say, hey, when my server receives a get request, so just a normal type in xyz.com into the browser, okay, for this URL, which is just xyz.com, okay, I want you to run this function. And what happens at this function is, so you have to pass it a callback, and this callback is always passed two things. An object called the request object. The request object represents all the details of the incoming request. So imagine you're at a restaurant, someone says, hey, I ordered this, and they give you a piece of paper with all the details of the order. That's the request object. Okay, I need to respond to that request. So the response object is going to have a bunch of functions that allow me to create a response, a way to respond to that request. So basically what I'm saying is that when a get request for this URL comes in, run this function. Okay, it's event-driven development. You're responding to events. The events are requests. Okay, so when that is the case, what we're going to do is we use our response object to send a response, and the simplest way to do it is use the send function. So I'm going to send a response, and we're going to say hello world. Okay, so our server has now been designed to respond to this particular order. So if someone makes this specific request, asks for this specific URL using specifically a get method, we will respond. Okay, but my server needs to be told to turn on. Okay, which means the server needs to be told to listen. So there's a function built in, listen, that essentially tells the server to start listening. But whenever you tell a server to listen, it has to listen on a TCP/IP port. So every computer has this way of communicating with other computers called TCP/IP. And the way it works is that messages can come into your computer or whatever computer the server is running on. And just kind of like, imagine your computer is like a town. Well, everybody has a different address. Okay, so all the different servers running on one computer can have different addresses referred to as ports. Okay, up to like 65,000. Okay, so usually when you're doing development, a very typical number is 3,000. So we'll say, hey, our server is going to be listening on port 3,000. Okay, so out of all the ports on our computer, we're going to say this server is listening for any request. So any orders that come in on port 3000. Okay, they're not listening for requests going to anywhere else, just the ones that go to port 3000. And then we can pass in a callback, and that this function is going to be run immediately as the server listens. The reason you would do this is because you generally want to console log something, like the server is listening on port 3000. And the reason you want to do that is because otherwise you have no output on the terminal for you to know that the thing's working. Okay, so generally you want that log so you have that visual confirmation that this happened. So now we can use our npm run dev script to run our server. Okay, and you can see here the server is listening on port 3000. Okay, so see, our server is now running on our computer. Okay, so the backend is running on port 3000. Okay, now from the front end, the browser, I can go make a request to that server. So since this server is on my computer, the address for my computer is either 127.0.01. That's the IP address of always of the computer that you are on. But to make life easier, built into computers is the term localhost. Localhost refers to 127.0.01, your computer. Okay, so basically I'm saying, hey, I'm sending a request to the computer that I'm currently on. Specifically, I'm sending a request to port 3000. So that's what that :3000 means. So port 3000 on this computer. Okay. And if I hit enter, see, I get hello world. Okay. Because hello world, see, that's just the main page. And see, this is, like I mentioned, this is always the request for the main. This means like the main page. It means like nothing. There's nothing after the domain name. Okay, neat. So what if we create another route? So we'll say app.get/cheese request response. And the cool thing is you can not just respond text, you can send full-on HTML. So I will send like, hey, let's do a h1 with the term queso. Okay, and see my server is restarting because we have that watch mode on because we're using the dev script. If I was just using node server.js, I would have to restart the server. You can always, if you never need to shut down the server, it's just Control-C. You just type in Control-C in the terminal and it'll shut down the server. But I would have to do that, then restart it, do it, then restart it every time I make a change. But because I have the watcher on, it'll restart it every time I make a change. Okay, but now let's try this out. So notice that this route, so I'm saying, hey, if someone sends a GET request and they request the URL/cheese, then send them this. So that means just at the end of the URL, I would add /cheese. That's the path that they're talking about. And see, that would take me to the queso. Now, what if I went to like /bread? See, I get this, cannot get bread, because I've made a GET request to /bread. But according to my menu, if you think about that restaurant analogy, like this is my menu at my restaurant, there's nothing on the menu that says get request to /bread. I have a get request for the root. I have a get request for /cheese, but I don't have any way of responding to any other types of requests because I haven't added them to the list. Like, so again, that's all the server's doing. The server's just sitting there. It's listening for incoming requests, and then based on these functions, which are referred to as routes, okay, based on the routes that I create, they will respond to those requests. Okay, now typing up full on like full on HTML in these strings, that seems like a little tedious if I wanted to do like a full on web page. That would kind of suck. So usually what we do, we put our HTML in an HTML file. We put the we put our CSS in a CSS file. So what if I did that? What if I just went in here and I created, like, let's say, a file called index.html. We'll call it whatever .html. Okay, and then we put here like some HTML boilerplate. h1, this is an HTML page. So what if I want to send the user this? Well, let's try that out. So I can create a route, app.get / whatever, request response. So again, you always have to pass in that callback. And response. This time we want to do, there's another function here called send file. So this is going to allow my server to send a file back to the browser. And for this, you actually have to send over the absolute path. So I can actually right click on here and I can copy the absolute path by using this copy path command. Okay, and then I would put that in a string. Okay, and there's like the absolute path to this file. So now let's see what happens. If I go to / whatever now, / whatever, it works. It sends me the HTML page. Now that HTML page is front-end code. So even though my server delivered it, the actual HTML file doesn't get read until it hits my browser. Okay, so there's like that line between front-end and back-end. Okay, that receiving that request and saying, okay, which one of these routes matches the request, that's happening on the back-end. And then the sending of the file is happening in the back-end. But when the browser receives the file and says, oh, hey, I got an HTML file, let me read it, that's front-end. Okay, just to kind of think through like, hey, what point am I crossing the line between back-end and front-end? Cool, but see, this is kind of like tedious, okay, right? Wouldn't it suck to have to write a route for every file that you want to make available to the end user? So typically in most back-end frameworks, you have the ability to designate what's called a static file server. So what you can do is you just create a folder, and basically files in this folder will be mapped to URLs automatically. So that way you don't have to create a route for each file. Okay, so typically if you use something like a Netlify or Vercel to deploy just front-end only projects, that's what they're providing you. They're providing you a static file serving for your project, which is usually, pretty simple and lightweight. So how does that work? Well, what I can do is I can create a folder. Usually what people do is they'll create a folder called public. Okay, this will be their static file server. Okay, and then what I can do is I can go in this folder and create like an index.html. Okay, and be like, do h1, be like, this is from the static folder. Okay. And what you do is to set up the static folders, you have to use what's called middleware. So we're going to register what's called middleware. Middleware are just functions that run, but they're not the end. They're not necessarily sending a response. This one might send a response, but not necessarily. And this is built into Express. So basically what you do is you do app.use. App.use is going to be the function to register middleware. And the argument to app.use is going to be a middleware function. There's a bunch of built-in ones to Express. We don't want to get too deep, go down too far the middleware rabbit hole. But in Express, there's a function called express.static that creates a static server. But that static function needs an argument, needs a name of the folder that's going to be the public folder or the static folder. So in this case, I'm saying, hey, this folder right here, the public folder is going to be use a static folder. So now if I go to the main page, notice I'm getting this from the static folder. Okay, notice, but wait a second. Alex, didn't you tell me that this should respond to that request, to the root URL? Why didn't I get this hello world? Well, the way Express works is that it's going to run these in the order that I put them in. So in this case, this is happening first. So what happens is it runs into this, and then it's going to see that, hey, in the public folder, there is an index.html, and index.htmls get mapped to the root. Just to show another example what I mean, if I create a folder in here called cheese, and then I copied that index.html to that cheese folder, and I just change that to say from the static cheese folder. Okay, if I type in like /cheese now, okay, that index.html gets mapped to the cheese folder. Okay, so that root basically gets mapped to the public folder, and then so forth and so forth. Okay, so just to keep in mind. But now if I were to move this and I were to put this below this route right here, now this route happens first, so that would be the first thing to send a response, because every request can only get one response. So if I were to do this now, and I go back to that main page again, see, this time I get the hello world because that comes up first. So keep in mind that when you write your server, these routes, the order that you write them in can affect what the response is, because that's typically a problem people run into, where what happens, they might write one route where another route before it can essentially satisfy the request. Okay. But yeah, so essentially I could just build out my whole, server out of this public folder, or I can build my whole website out of this public folder if I wanted to, and all, we would all be good. Okay. Also, what I can do is I can make endpoints that deliver data. Okay. So for example, I could make an endpoint. So we'll say app.get. I will call it /JSON request response. And this one, instead of sending just like text or it's going to send JSON data. So we're going to say response.json, and it's going to send. What we do is we pass it a JavaScript object, and it'll convert the JavaScript object to JSON. So we'll say message hello. Okay, now if I just to show you that it works, if I go to /JSON now, see I get this JSON data. Okay, so you see I get this JSON data. So now I could put in some JavaScript on this page here. So let's go back to this index.html. I can put I can run some JavaScript in here to go make an API call for that data. So I can be like fetch to /JSON. And notice I didn't have to put the full URL because they're all part of the same domain. Like the first part's the same. I can put a relative URL because it's going to assume that first part, that localhost 3000, doesn't change. If it was a different, like let's say it was even localhost 3001, then I would have to type out the whole URL, http://localhost:3001/JSON. Okay, so relative. So generally, when things are part of the same application, you can use relative URLs. When they're cross-site references, then you need full URLs. But I can say, hey, give me that /whatever .json gets, and then I can just do a .then to get the response from that, and we'll return the response.json. And .then we'll get the response from that, or let's call that the data, and we will console.log the data. Okay, let's just see if that works. Okay, actually what I'll do is I'm going to make that an alert, so that we don't have to open up the alert data.message. Or actually, let's just do this alert JSON.stringify data. So that way we can see the string version. It'll run. I'll get an error, or it'll say something funny if I just pass a JavaScript object. Okay. So let's see here. Let me go back to the main page. Okay, and see, that API call was successful. See, it got that message from that API. So what I can do is I can create other routes, and that's typically how it would be used. You would create your website, and then in these other routes, you might make API calls to, to your database, or you might make calls to your database. You might make API calls to a third-party API. Things that require you to use credentials. Okay, because the thing is that I can't inspect your server code. Like if I go to inspect here, all I'm going to see is what was sent back, which is the HTML file. I can see the HTML file. I can see that. Okay, that's great. And I can see that request was made back to my server. So see, like there's the request to the JSON endpoint. Okay, it worked. Wonderful. But I can't see the actual server code. So in that case, if in the server code is where I actually make the API call to like that third-party API or to my database, and I have to pass like sensitive credentials, well, it's not visible. Okay. So that protects me from people who can see it in the front end. I still want to like prevent it from being on GitHub. So that's where the .env comes into play. So what I can do is if I have a credential, I would put it in the .env. Okay, so let's say I'll make a variable called credential. So it's always like the name of the variable equals, and then you would put whatever. So we'll say cheese equals cheese. And long as I make sure to run this .env function, this .config function at the top of my file or somewhere in my file, then I have access to that variable. So now all those variables get stored in an object that's built into Node called process.env. Okay, in short, it's really just an object with all the environmental variables. So not just the variable we just declared, but any environmental variables that currently exist in our terminal session. But you don't think about it that deep. The simplest way to think about it right now is that technically that credential variable that we just created is in there. So if I were to console log this process.env.credential, okay, because again, in our .env, we defined credential, okay, we can see that, okay, there it is. It got console logged, okay? And notice that the console log from the server showed up here, while the logs in the front end, so again, logs that run in my front end code are going to show up here. Logs in my back end code are going to show up here. So you always want to be careful, like where are your console logs? Are they, in my JavaScript that's running in the browser, or are they in my JavaScript that's running on the server? Because that's going to determine where you should look for the log output. Okay. But that's a pretty good introduction for now. So basically you can kind of use that to start kind of playing with more. I have plenty of other videos on ExpressJS. So just look up, Alex Merced ExpressJS to go even deeper. But this should get you started down the road of getting comfortable with writing backend code and kind of what's going on here. So play around with some of this, try a few different things. You'll see it's pretty neat. My name is Alex Merced from AlexMercedCoder.dev. Have a great day and enjoy. Make sure to follow me on Twitter at AlexMercedCoder and have a great day.